Good evening to all. Is the audio clear? And video? Thank you. So, any queries to daily test? Say. Okay, don't worry. Then please keep a note of those problems. At your free time, please solve the problems and you can ask the doubts in Telegram. Since everyone is concentrating on prelims, so please go ahead. So randomly for today's topic also, I will post the daily test. If we have done, it is well. Otherwise, we will discuss after prelims or randomly at your free time. Thank you. So let us start our today's session on Cauchy-Euler equation, Legendre's equation, and reduction method. So this is the module of today's session. On discussing these three methods, higher order differential equations will be completed completely. Then Laplace transforms will be done by Venkana sir later. Okay. So this completes 70% of ODE. So shall I continue with the part? In a due course of time. Since sir has been resumed today with complex analysis, simultaneously he will cover this thing also. Fine. Otherwise, I will come back and I will finish the part. So first of all, Cauchy-Euler equation is, it comes under the part of variable coefficients. The typical form of Cauchy-Euler equation is x power n d power n plus some constant into x power n minus 1 d power n minus 1 plus so on plus xd plus constant say. This is the general form of Cauchy-Euler equation. In a simple manner, since we are discussing about second and third order differential equations, the simple technique here to follow is the power of d and x must coincide. If the given equation is not in that form, we try to convert into that form and we will solve the equation. So you can simply say like this: x square d square plus some constant into xd plus some value of y is equal to q. So it is a second order differential equation which is Cauchy-Euler equation. See, power of d and x must coincide. Fine. Are you getting the idea behind it? So please take a note of that. The procedure to solve this equation is, in place of xd, we go for a substitution, right? In other words, we are converting variable coefficients into constant coefficients by means of a substitution. The thing is, you substitute x equal to e power t or t is equal to log x. So if you consider the derivatives, say if you have written dy by dx, you can written as dy by dt into dt by dx. And we use the symbol say theta for d by dt. As per the problem, Capital D stands for d by dx. By using this substitution, it will be converted into constant coefficients, and these values will be replaced with the following. So we replace xd with theta, x square d square, theta into theta minus 1, x cube d cube, theta into theta minus 1 into theta minus 2, and so on. By doing the successive differentiation here, you will get these values. However, in exam, we just mention these things only. Substitute x equal to e power t, or t is equal to log x, then xd is equal to theta, x square d square equal to theta into theta minus 1, and so on, where theta is nothing but d by dt. Apart from theta, you can use another symbol also. That's up to your choice. Okay? Are you getting the idea? Now, by doing these substitutions, the remaining procedure is as usual. So, we are going to evaluate y. So, y is equal to yc plus yp. We follow the regular procedures or methods what we have discussed so far. So here, in writing yc, we will write like this: c1 e power t plus c2 e power minus t, like that, where after evaluating the complete answer, in place of t, we go for the substitution. That is the approach or methodology to solve this problem. So please take a note of these substitutions, then I will go for a problem which gives you clear idea. After noting this, please inform. And in examination point of view, this model is most important. The weightage will be 15 marks whenever a problem on Cauchy-Euler equation is asked. After noting, please inform. The thing you were saying this. Yeah. Is this accepted? Say. Similarly, again you take the same value, go for double differentiation. I will give the differentiation part. I will post in Telegram. You can check that if you have a doubt with regard to the derivation. Fine? Right. So let us take the problem. So x square into d square by dx square minus 2x into dy by dx, and then minus 4y equal to x square. Please take a note of that. So if you write the operator form for this problem, it is x square d square minus 2xd minus 4 of y is equal to x square, where d stands for d by dx. Again, we mentioned that put x equal to e power t, or t is equal to log x, and the remaining follows. xd is equal to theta, x square d square equal to theta into theta minus 1 and so on, where theta is equal to d by dt. So substituting these values, theta into theta minus 1 minus 2 theta minus 4 of y is equal to e power 2t. Please check that. And if you simplify this form, theta square minus 3 theta minus 4 of y is equal to e power 2t. Any questions here? So can you find the complementary function yc here? Right. So finding the roots is as usual. We mentioned that m square minus 3m minus 4 equal to 0 is the auxiliary equation. So m equals to minus 1 comma 4. Hence the corresponding yc is given by c1 e power t plus c2 e power 4t. However, you can substitute the value of t here. This one will be c1 e power minus log x plus c2 e power 4 log x. So which gives that c1 by x plus c2 x power 4. So please confirm that whether I have done correctly or not. So we are going to find the particular solution yp. So for yp, 1 by f of theta into q or q1 you can call. So 1 by theta square minus 3 theta minus 4 of e power 2t. So we follow the regular procedure. Whenever e power ax is there, the power a should be substituted in place of the differential. So if you substitute the value is 1 by 6. This will be 1 by 6 into e power 2 log x. So x square by 6. Therefore, general solution is given by y is equal to yc plus yp. Please check that. Yeah, minus. So all of you agree with that? So I want to take 2 more models on this Cauchy-Euler equation, which gives you the variation. Shall I erase this? All of you have noted. So the problem is x cube d cube plus 3x square d square plus xd plus 1 of y is equal to x plus log x. So I ask you to substitute the respective values. So will it satisfy the criteria of Cauchy-Euler? Since the power of d and power of x both coincide? Fine. So substituting these values, I'm going to write the value. You can check on that. So please confirm the value by doing yourself. Fine. So can you write the complementary function? So I will write the roots that m is equal to -1 comma m is equal to 1 plus or minus root 3i by 2. Please go for the roots. Fine. So the complementary function is given by yc is equal to c1 e power minus t plus e power t by 2 c1 cos root 3 by 2x. This one is used c2, c3. c3 sine root 3 by 2x. I mean t we have to take here. Here the differential is t here. All of you agree with yc value. So substituting the respective t value, it will be c1 by x plus e power log x by 2 of c2 cos root 3 by 2 log x plus c3 sine root 3 by 2 log x. Please check that. Okay. Now we find yp. So 1 by theta cube plus 1 into t plus e power t. We are going to apply this value to the two functions individually. So 1 by theta cube plus 1 of t plus 1 by theta cube plus 1 of e power t. For this, we are going to use x power n module. We have to feel that it is t power n like that. So we are going to write the denominator as 1 plus or minus something. So if you apply that criteria here, it will come as 1 plus theta cube whole power minus 1 of t plus here by substituting the power 1, we are going to get 1 by 4 e power t. Applying the expansion, it is 1 minus theta cube of t plus 1 by 4 e power t. So which gives that t plus 1 by 4 e power t equals to log x plus x by 4. X by 2. Oh, sorry. Fine. Accepted? So please take a note of that. Then I go to the other model in this. Here x power 4 d cube plus 2x cube d square minus x square d plus x of y is equal to 1. So will it come under Cauchy-Euler equation? So to bring into Cauchy-Euler equation, we have to divide with x on both sides. So it will come as x cube d cube plus 2x square d square minus xd plus 1 of y is equal to 1 by x. In order to say that it is Cauchy-Euler, x and d must have equal power. Now you substitute the respective values here and give me the output in theta. I will write the right side value. It is e power minus t. You can check on yourself. Theta cube minus theta square minus theta plus 1. So all of you check on yourself whether the coefficient achieved correctly or not. Then tell me. If possible, find the YC also. Give me the roots. Plus theta. Is that correct? Plus theta. Minus theta, right? Because this is minus xd, this will be replaced with theta, right? All of you agree with this coefficient? Any doubts? Fine. If you find the roots of it, m cube minus m square minus m plus 1 equal to 0, m comes as 1 minus 1, 1. So the corresponding YC is given by C1 e power t plus C2 t e power t, because 1 is the repeated root, and then C3 e power minus t. So transforming in terms of x, it will come as C1x plus C2 x log x plus C3 by x. Accepted? Fine. So coming to YP, so 1 by theta cube minus theta square minus theta plus 1 into e power minus t. Since minus 1 is a root, obviously denominator becomes undefined. So if you make it into factorization, theta plus 1 into theta minus 1 to theta minus 1 e power minus t. So this factor we are going to leave. So t by 1 factorial 1 by, if you substitute minus 1 here, accepted, it will become plus 4, right? So equals to t means log x by 4 into e power minus t means 1 by x. There you are going to write final answer y is equal to yc plus yp. I just want to take one more on this model. I think there we can wind up our discussion on this Cauchy-Euler. Is that sufficient, the practice on Cauchy-Euler? By taking one more problem on it. If you have noted this, please inform. I go with the next one. If you require other kind of models also, I will go with them. With respect to Cauchy-Euler, if you require more practice. So shall I proceed? Okay. So consider the problem x square d square minus 3xd plus 5 of y is equal to x square sine of log x. It is given in that Cauchy-Euler form typically. So you please give me the corresponding coefficient here. By substituting the respective values. Theta square minus 4 theta plus 5. Is that right? Yeah. So theta square minus 4 theta plus 5 of y is equal to e power 2t into sin t. So can you post the values to me? 2 plus or minus I, that's fine. So m is equal to 2 plus or minus I. So yc is equal to e power 2t into c1 cos t plus c2 sin t. So converting in the notation, it will be x square into c1 cos of log x plus c2 sin of log x. Accepted? Fine. Let us go with yp. So yp is equal to 1 by theta square minus 4 theta plus 5 into e power 2t into sin t. So here we are going to use the methodology that e power ax into v is of the form. So by applying this technology, e power 2t comes to the front. Theta should be replaced with theta plus 2 whole square minus 4 into theta plus 2 plus 5 of sin t. So can you simplify this for me? The value? Theta square plus 1 or theta square? Yeah. So we are going to apply the formula here. So e power 2t into minus e by 2 into 1 of cos t. Can you remember this formula? All of you. 1 by d square plus a square into sin ax is equal to minus x by 2a into cos ax. Accepted? Right. Now substituting the values here, it will be minus x square by 2, t means log x, into cos of log x. And y is equal to yc plus yp is the general solution. So the ideology of Cauchy-Euler equation is totally based on the 5 methods which we have learned earlier. For ax, x square, cos or sine functions, e power ax into something, x into sine or cos functions. So if you know these methods perfectly, Cauchy-Euler is nothing but just converting variable coefficients into constant coefficients, applying the previous methodology as it is. At the end, we replace t with the corresponding function value. Fine? Right. If all of you have clear with Cauchy-Euler, then I am going to take with Legendre equation. Please take a note of that. So did you feel any difficulty earlier in solving the problems using the 5 methodologies discussed? The 5 formulae. The only thing left with you is just having a practice on them. Am I correct? Yeah. Consistent practice makes you to do them perfectly. That is the only thing. Because ODE is the simplest and easiest one compared to all in paper 1. So shall I erase? Okay. So let us go with Legendre's equation. The methodology in solving Legendre equation is just similar to Cauchy-Euler. As we know what is meant by Cauchy-Euler equation, let me write it again. Suppose if we have taken a second order Cauchy-Euler equation. So here we are comparing that x and d should have equal power. Similarly, apart from x, if I have taken a function, a linear polynomial, let me say ax plus b, satisfying the same criteria that this polynomial and d has equal power. So ax plus b whole square d square, ax plus b into d plus some value of y is equal to some function. Here, so this is nothing but Legendre's equation. Are you getting the idea? Or no? Right. So, as we are going to substitute the function earlier, so here we substitute that, put ax plus b is equal to e power t, or t is equal to log of ax plus b. Again, going for the successive differentiation as we do earlier, here also we replace the same thing. So ax plus b of d will be replaced with a into theta. The same things, yes, only polynomial. The problems will be asked by taking the first degree polynomials, usually. Not more than that. I can say it was asked very less compared to previous year questions. Majority of the questions are based on Cauchy only. Occasionally you can have Legendre's. So the problem is typical, say. Otherwise, this won't be given in the exam. But if you know the ideology, it is very easy for you to solve. So, ax plus b whole square into d square is equal to a square into theta minus 1, like that. So, same Cauchy-Euler values will come, theta into theta minus 1, theta into theta minus 1 to theta minus 2, and so on. The only thing is, you have a coefficient here, a square, a cube, a power 4, and so on. Remaining procedure is as usual, as we solved earlier. Nothing is changed. Okay? I will post the derivative part, how it comes. In the Telegram, you can check at the free time. The differentials are going to vary. Accepted. So please take a note of the approach. We will take randomly 1 or 2 problems on this method. After noting that content, please inform. Okay. So please take a note of the problem. After noting, please inform. Shall I proceed? Yeah. So here you have to take x plus 1 is equal to e power t. You please compare with this that it is of the form ax plus b, where a value is 1, b value is 1. So here you have t is equal to log of x plus 1. Substituting these values in the given equation, you have theta into theta minus 1 plus theta plus 1 of y is equal to 2 sine t. And you can simplify that. Accepted? Now I think that you can have the correlation between Cauchy-Euler and Legendre's, everyone. Initially, I have taken a simple problem for you. Right. So if you write YC, so it is C1 cos t plus C2 sin t, nothing but C1 cos log of 1 plus x plus C2 sin log of 1 plus x. It will come like that. Accepted? And then coming to yp, so 1 by theta square plus 1 into 2 sin t, applying the same formula what we have learned earlier. So minus 2 into 2 by 2 into 1, I mean x into cos t, 2 gets cancelled. Here you have to take t here. So minus t cos t, minus of log of x plus 1 cos log of x plus 1. Please check on that. And general solution is given by y is equal to yc plus yp. So can I take the other one on the same model? Can I erase this? Fine. So note down the problem that 1 plus 2x whole square d square by dx square minus 6 into 1 plus 2x into dy by dx plus 16y is equal to 8 into 1 plus 2x whole square. Please go with it. If you have applied the formula, 2x plus 1 will be equivalent to ax plus b. So a value is 2 here. So 1 plus 2x into dy by dx will be replaced with 2. Theta y. accepted, and 1 plus 2x will be taken as e power t. Please check, and t is equal to log of 1 plus 2x. Is anyone has any doubt in replacing the function with corresponding differentials? To anyone? Or no? Is that clear to all in the substitution? Fine. So you please simplify that and give me the output. In the middle I will write. Let us go on checking that. So on substituting these values, you are going to get the function as 4 theta square minus 16 theta plus 16 of y is equal to 8 e power 2t. Accepted? Please check. Fine. If everyone has achieved at this step, I will go further. So what are the roots? Yes. So C1 e power 2t plus C2 e power 2t into t, nothing but C1 as t is equal to log x. Do you accept for this value? The value of yc. C1 into 1 plus 2x whole square plus C2 into log of 1 plus 2x into 1 plus 2x whole square. Fine. So let us go with yp. Yp is equal to 1 by 4 theta square minus 16 theta plus 16 into 8 e power 2t. Since 2 is the root of it, we have to remove the factors here. So can you do it on your own? Please go ahead. I will write the solution part for you, you can check. Square e power 2t on removing the factors. If anybody has any doubt, you can ask. We will re-explain that. Any questions for anybody here? How the value of t square e power 2t will come? Okay. Thank you. So I just want to take one small thing on this Legendre's equation. I just want to give the idea here. I don't want to solve the problem, so that you can have the typical thing or the difficult thing on Legenders, which gives an idea how a difficult problem will be asked on Legenders. The procedure is simple, nothing difficult at all. The simplification part in the problem is simple. Okay, I will proceed now. So please note down the problem that 3x plus 2 whole square of d square plus 3 into 3x plus 2 into d minus 36 of y is equal to 3x square plus 4x plus 1. Now see, on observing this, we can say that it is the problem based on Legender's equation because the linear polynomial is there. 3x plus 2, 3x plus 2. Straight away you can substitute that 3x plus 2 is equal to e power t or t is equal to log of 3x plus 2 and respective change will be made here. The only thing is how to simplify the RHS there. Because RHS should be converted in the known function, right? How to convert that? So that is my task for you. Can you elaborate that? Okay. So plus 2x minus 2x, that's a great idea. So 3x square plus 2x minus 2x plus 1, if you take like that, fine. So one way you can say x into 3x plus 2 will come, then you are left with this thing. However, I will write the answer, you check on with you. It is going to come like this. E power t minus 1 into e power t minus 2 by 3 plus 1. In a simplified manner, e power t minus 1 into e power t plus 1 by 3. At the end, the answer is e power 2t minus 1 by 27. The right hand side value will come like this on simplification. So I am giving the answer there. You try on your own. If you didn't get, I will post it separately. My intention is the difficulty will be asked in this model, the maximum difficulty. However, if a question is asked in this model, the weightage should be definitely 20 marks on Legenders. Because to convert the right hand side, we require time. So 1 by 3 into 3x plus 2 whole square minus 1 by 3, fine, that is a good idea. This is what you have tried. Minus 1 by 3 is also in the denominator. Okay, however, 1 by 3 separate. Okay, right. I am giving the ideology here. Don't think more about this problem. I am giving an idea that the maximum difficulty will be asked in such a way on the right hand side. Straight away, the function will not be given on substitution. You have to modify the function, then only you are going to get the idea. Okay. So the simplified part in the book, I have given that e power 2t minus 1 by 27. Take it as a practice. I will post the solution separately. Please don't bother. Because in the examination point of view, Legenders is given less priority. So as we have mentioned, 3x plus 2 whole square minus 1 whole by 3, right? Yes. It will come in that manner. Thank you. So if everyone is clear with Cauchy-Euler and Legenders, I am going to talk with the method that is reduction method. Shall I complete that? Just note down the problem. Nothing is required for you except this. Just note down the problem and the thing what you have mentioned there, the right hand side part. For ODE, I have done 70% of it. The only thing left with ODE is Laplace transforms. We covered at the most 5 or 6 sessions by Venkana sir. However, if sir didn't find the time, I will come back and I will finish that part, Laplace transforms. Could you recollect total how many classes we have taken so far? At the most 15 or 20? 20 hours at the most. So if everyone is well versed with Laplace transforms, the maximum thing we take for it is 30 hours, 15 sessions. So I will come back because I am not going to take the other topic because I have to do another work. But I will be back soon. In the middle, Venkana sir will cover the classes. May I know how many of you are attending for the test series this year? Going to be started after prelims in the month of June or July. 1, 2, 3, 4, 5. Thank you. Calci is allowed for the second thing without any hesitation. For first thing, I hope so it is also allowed. So let us go with the reduction method now. It will be interesting to you. So just please recollect the previous class what we have done. We have described a typical method that whenever you have taken a second order differential equation, there we are going to use the methodology that we are going to find one function u and y is equal to uv is the general solution, and where v is to be found using the formula Can you recollect this once again? Yeah. Here what happens if RHS is 0, then also we are going to apply the same methodology here, and usually this method takes somewhat a little time more compared to the regular methods. So for the same kind of differential equation, the second order, whenever one function is given, to find the general solution, another method is there, we call it as reduction method. Both are somewhat similar in the approach, but apart from remembering this big formula, one formula is given straight away. By substituting the values there, you are going to get the solution. Okay? That is the ideology. So to solve the homogeneous equation, that is when RHS is 0, that is typically R is 0, when one solution is given, to find the other solution V, we are using this reduction method. So I will write the formula. You please take a note of that, and I want to take just one or two problems on it. So we are going to make use of this method at the most whenever our general methods are not worked out. Yes, the right hand side part is 0 for the homogeneous thing. And one function is given, or you are going to make use of that by using p plus qx is equal to 0, etc., etc. That also you can use that. So here, if y is equal to f of x is a solution, then y is equal to c1 into f of x plus c2 into p into f of x is general solution. Where p is defined by integral please take a note of that. So we are considering the form in the value of p of x into y double dash. This kind of equation we are solving it. So please note down the equation form also. We are applying this method called as reduction method whenever the RHS is 0. So we are applying for the homogeneous thing only. So we can make use of this method whenever variation of parameters problem is asked with variable coefficients. Suppose a problem is given, let me say f of d into y is equal to q is asked on variation of parameters. In which f of d contains variable coefficients. Yes, we take one example also. Now see, this is typically nothing but a complementary function accepted. C1 into some function plus C2 into some function. So to apply variation of parameters, that is to calculate yp, we require two functions. In other words, to calculate the complementary function, reduction method is somewhat useful. So one solution we can easily find, or it will be given in the problem. The other solution we are going to make use of this by using this technique. And yp will be calculated by using variation of parameters. So let us take one problem here which gives you clear idea. One problem is sufficient for you. I hope so. So please take that x into y double dash minus of x plus 1 into y dash plus y equal to 0 where x is greater than 0. where one solution is e power x. Fine. So in the formula, I have written that v is equal to integral one function you have f of x whole square e power minus integral q of x by p of x dx. Am I correct? Okay. The formula which is mentioned there, right? So if you compare that, p of x is equal to x, q of x is equal to minus of x plus 1. So first we evaluate this value separately, and f of x is equal to e power x, which is given in the problem. So e power minus integral minus of x plus 1 by x dx, minus gets cancelled. E power integral 1 plus 1 by x dx is there. So e power x into power log x. Am I correct here in writing the thing? Okay. I have just evaluated only this part. Q of x by p, q of x is nothing but minus of x plus 1 by x. 1 plus 1 by x. Accepted with that value? Or no? So if we substitute the values there, integral x e power x by e power x whole square dx, v is equal to is x into e power minus x dx. Simplify the value is minus of x plus 1 into e power minus x. So do you accept with this step, yes or no? 1 plus 1 by x, right? So simplify here, it will be e power x plus log x. Accepted? Right? So if you separate the values, it is e power x into e power log x. So x e power x will come. Accepted, or still you have a doubt? Right. So this is v value, and the final solution is given by y is equal to c1 f of x plus c2 into p into f of x. So c1 e power x plus c2 into v means minus of x plus 1 into e power minus x into f of x means e power x. So you can feel the difference that the final answer is given by c1 e power x plus or minus c2 of x plus 1. So this is the complementary function value. So in this way, reduction method is useful to determine the complementary function for the homogeneous problems. For non-homogeneous, we have the standard methods, we stick on to them without any change. So this method has the main advantage whenever a problem is asked on variation of parameters with variable coefficients, so that one function in the complementary part is known, right? Other function we have to determine. However, if the two functions are to be determined by us, then what happens? We are going to follow the procedure that p plus qx, 1 plus p plus q, so on. Among these two things, obviously, one formula will give us a solution. For the other, we are going to apply the reduction method. So complementary function will be evaluated very easily. Rest of the part will be done by variation of parameters to evaluate YP. Okay. So here I want to conclude the discussion. If you have any other queries, you can ask. Otherwise, let us stop our discussion here. I will resume later. And if any doubts are there with you with regard to any approach of the previous problem so far discussed, I will take one doubt clarifying session tomorrow for half an hour to 1 hour as per your needs. Otherwise, there will be no more session tomorrow. This is the end of ODE on my side with regard to higher order differential equations. I mainly concentrated on solving the methods and procedures only, not the theoretical part. Laplace transforms will be taken by Venkana sir. However, if sir didn't find a time, I will come back. I will take this session within 5 sessions because it's a small part, because everyone has studied that thing at BTech level, doing Laplace transforms more. I hope so. So with regard to previous year questions or doubt clarification, did you require any session for tomorrow or not required? I request that you please post your queries. I will clarify your doubts. I ask that any procedural doubts are there for you with regard to a question. You're clear with that? See, we are mainly using this method to find complementary function, right? Even the Q is there, you can method find it. It is useful only for finding complementary function. In variation of parameters, what I am saying, when Q is there, for finding Yp, we have to use variation of parameters only. To find Yc, we use this method when one function is given to determine the other function. So especially when homogeneous functions equation is given, Q is not there, so it contains only Yc. That's why we are using this method. Because the previous method is somewhat difficult, right? P plus 2 by u into du by dx, etc. Variable separable. Otherwise, you are going to apply linear differential equation method there. Apart from it is straight away the simple formula. That's why we are using this. So for any procedure doubts, you post your questions in Telegram. So based on that, I will take a doubt clarifying session tomorrow. Or if the doubts are easily solvable, I will post a solution in Telegram itself. Right. These two things will be completed before prelims, complex and Laplace transforms. Take it for granted. May I know how many of you have studied Laplace transforms earlier? Years back, right? Same thing is done with DE also, but DE contains more methods. Laplace transforms, we have fixed formulae. So based on the formula, we are going to evaluate. That is the only thing with that. Thank you. Yes, variation of parameters for variable coefficients too. I have taken the problems on it also in the previous class. Just let me, if you have a doubt, just let me take one problem on that so that you have a clear idea. Just hold on a second. I will take a simple problem for you, which gives what I am talking about. Just hold on a second. So please take that this d square plus xd minus 1 of y is equal to x square e power x. Actually, this is Cauchy-Euler equation, right? Accepted? All. If the same problem is given for various of parameters, how to solve it? So if you say that, it will say p plus qx equal to 0. So what happens? Y is equal to x is a part of complementary function. Why I have taken to apply this formula, this won't contain any coefficient. So we divide the entire thing with x square. So it will come as d square plus 1 by x into d minus 1 by x square of y is equal to e power x. By converting the given equation into this form, we check the condition that p plus qx equal to 0. So y is equal to x is a solution. So what happens? If we calculate yc is equal to c1x plus c2 into something. Accepted? Yc is nothing but c1x plus c2 into something. To determine the other function, if it is possible to check with other conditions like 1 plus p plus q, 1 minus p plus q, etc., it is okay. Otherwise, I have given the reduction method earlier. We are going to apply the same reduction method here. Okay, let me check with this, whether the method is useful here or not. So here is equal to 1, p is equal to 1 by x is one solution. So you have p is equal to integral f of x whole square e power minus integral q of x by p of x dx. Can you evaluate that? By taking the respective values here. So I will say on the simplification you are going to get the yc value as yc is equal to c1x plus c2 by x. So one function is x, another function is 1 by x, and you are going to apply variation of parameters yp is equal to a into u plus b into v as usual by writing the values of a and b. Is it clear now with regard to variable coefficients of variation of parameters? Right? So that is my intention there. Yeah. That kind of problem is asked earlier. Accepted? Right. Yes, for 15 marks weightage. So I think as per the examination point of view, I have covered all the models. So once you have cleared with the prelims, you do the thing as I have mentioned in the previous session, taking that one person should take 1 year, 2010, 2011, 2012, etc. So you allocate yourself to solve the question and post it directly in Telegram. Everyone will take a copy of that. The questions which are difficult for you, you left them as a doubt, and we are going to solve it and post the respective solution. So may I know when you are going to do, after prelims or before prelims? We got to ODE only, up to higher order differential equations. Okay, so you take after prelims. So that is the end of our session. For tomorrow's session, you can ask your queries in Telegram. So based on that, I will take a doubt clarifying session for that. Otherwise, I will clarify your doubts in Telegram itself. So that's all for the day. Thanks to all.